I'm really happy to be here with you because this is my first time in Verona, so I can enjoy the trip and the conference. I'm here to talk about Node.js, feature flipping, Git stuff, and everything. I'm formerly a front-end developer, so I'm not that involved in Node.js ecosystem, but I work with Node.js in a previous company. So, so I'm now doing some DevOps stuff at a hosting provider, and I try to find a way to make my deployments more easy to do and more easy to flip when I push some new features in production. So, here's the story. I have a code base, a big one, as you can see. This one is virtual, but let's say we have a big code base. And this code base is used by a lot of people, kind people. And I have some stuff to do, and I have some improvement to made on the code base. And I finally pushed a new feature in production, and that feature concerns the authentication. So I pushed it in production, and suddenly everyone is locked out as a system. And so everyone can access the sign-up form, can pull in their credentials and log in, and the page is totally fine, and the user is logged in the system, and when the user refreshes the page, it's suddenly logged out, and you have to sign up again and again and again. And guess what? This is exactly what happened in GitHub 1 month ago. I have a whole day without being able to log in GitHub in any way, in any manner. So we need a way to roll back our solution in this kind of situation. And fortunately, GitHub had this kind of system, but I don't know why they didn't roll back their authentication system. I guess the modifications were too huge in the code base. So the solution is probably to use feature flipping. So what are the feature flags? Feature flags is when you are developing new solution, a new feature in your code base. You don't want to push everything in production right now to every user. You just want to push your feature and test it to a small amount of your users, and then increase day by day the number of users that can test the solution, and you can roll back at any time to disable the feature if there is any problem in your code base. So feature flag is just a toggle that is used to hide, enable, or disable a feature during time. In your code, it's as simple as that. You just have a flag in a feature flag repository, and you test the flag, and this is just a Boolean, and you just have to enable or disable your code directly in production. There is another solution that is called branching, which is opposite to the feature flag. You just come from the master, pull a new branch for the feature, you're working on the branch, you're pushing this branch in production or in a staging form, and if you want to add another feature, you have to pull another branch from master or feature branch, I can't recall, and then another one, and it's just a spaghetti branches just after that. So feature flags is a way more flexible and easy to use. But if you want to do that, you have to test which user can access to which feature and which flag. So you have to use ACLs. ACLs are just access control lists. So you define roles, you define eventually parent roles, there are groups of users. You just associate some users to some roles, and a user can have different roles. And then you enable some kind of solution, some kind of feature, or some kind of rights of permissions to those groups and those roles. So This is something like this. You can have another repository like the feature flags. This one is for the ACL. And you allow the guest role to view blogs, which is acceptable, I guess. You can allow member to edit, view, or delete some blogs. And then when you have defined this kind of rules and permissions, you can test them. So you can test if a user is allowed to access different action on a resource. You can check some permissions to check if the user can have access or modify the permission. And you can use it as a middleware to directly enable your access control in the permission. If you use both access controls and feature flipping, you can easily test at any time if a user is allowed or not to access to an experimental feature in your code base. Problem is, when you're doing some kind of modification like this, you often have to change your database schema for some modifications, for some different access. So you have to deal with database migrations. Problem is that a migration is something really huge and sometimes really complex to do in production. So you have to run your migrations and ensure you don't break your whole system. So a database migration like this one is a schema migration is performed in database when it's necessary to update or to revert your database in its previous state. It can be done easily with Node.js, with some framework to do that. I forgot the link to the framework that I use for database migration, but I will add it in the slide later. You just define a migration by defining a module with two functions, up, which is run when you do the migration, or down, which is run when you revert the migration. And you just have to run that after in a simple npm script. I just wrap the call in a custom script, so I can run a npm run db migrate up and down, and eventually specify a version to ensure that you migrate to or from a version, a dedicated version. Okay, so this is some cool stuff to do, modification, testing on your code base. So how to deploy it in production without a mess and without a centralized system, especially when you're working with many people remotely on a huge code base. And I say that because I'm working remotely in various companies for more than 10 years now. So I know that when every developer can push some code in production, it's sometimes useful to have a simple system to deploy. So my proposal is to use hooks and Git hooks, not this one. Even if this guy is some kind of interesting guy. So the idea is to use the Git hooks. Git hooks are some scripts that are called when you push your repository and a dedicated origin, a dedicated endpoint, remote. And you can couple it with functional reactive programming. Is there any people that already tried to do functional programming? Yeah, 10 hands at raise, or at least something like this. Okay, the interesting idea behind functional programming is that you can, it's just kind of map and reduce actions. So you can, at any point, plug your system on a different source, and you can interact with your different flow of actions. What is interesting with functional reactive programming is that you can use any kind of stream to adapt your code and to plug in your code. So you can do that with some stream that is created by a user, exactly what we done here when we click on the button and you finally choose to fire that every 500 milliseconds and so on. But you can also do that by using Node.js streams. And that's why it's really interesting. Because when I use Git hooks, I first start with a git bear. So a git bear repository is a Git repository without a working space. This is just the content of your .git repository when you are working locally. And this is exactly what you have when you host Git repositories on server. So the first step is to init your repository on the server side. You just SSH init and do a git init bear. And with the flag bear, you are just initializing a repository that isn't containing your working space. You have just the Git objects. This is something like this. I clean it up because otherwise it's a lot of useless repository for this talk. So you have several kinds of directories, and especially a good one, which is hooks. And in the hooks, you've got a bunch of various scripts, and those scripts are called when you perform a dedicated action on your repository. The post commit is called when you do a commit on your repository, the post receive when you push something, when you do a git push on the repository. The update occurs every time you push a new branch on your repository. So update is called on every branch, and post receive only is called just once when every branch are pushed on the remote repository, and so on. So when you have initialized your repository, you just have to set it as a new origin, a new remote on your developer side. So just a git add remote staging, and the repository repository URL, and then you can define hook scripts. So I mainly use the post receive because this is the one that is called when every branch are pushed on the remote repository. So first thing, this is bash script. Nobody's perfect, but it works well. First thing is to define a git, the git directory, so the directory where the sources are held by git. And there is a simple while loop that is called and read the oldest revision, the new revision, and the reference. The reference is a branch name when you push some code. So to make things easier to maintain, I use post-receive scripts, and I have developed various scripts, and I hold them in a Unix way, in a repository.d, in a directory.d. So I first test if my directory exists, then I loop over the various scripts in the repository, and I source them. And it magically executes everything in the repository and in my scripts. You can filter the various branch, because when you run in an update, you probably don't want to perform your actions on every branch, but only on the production branch or in the staging branch. So you just have to test if the reference that is passed to the script is equal to the branch you want to test. So here is just code that is executed when you run your code on production branch. It's, for instance, easy to use for deployment. And when I deploy, exactly what I do when I deploy those slides. This is the same way I deploy them. I just check out my current Git directory in the folder that is served by my HTTP server, and when I do that, I just deploy my branch in production. I didn't lose everybody. Okay, it's fine. Okay, cool. So I can do that with deployment, but I can also do that on npm scripts. So I can run various scripts. So I can, for instance, run db migrate to migrate up to the 2018 Node.js IT version. And it's done. So it's easy to perform your various migration when you are doing some modification on your code base. And on the developer side, it's as simple as just doing a git push. You're just pushing your branch to the staging remote endpoint, and it's okay. It's enough. Everything is handled on the server side by the DevOps team or the people who's in charge of the production deployment. So, okay, I did my git push, I pushed my feature. This feature is now deployed in the staging branch or production branch, something like this. But I need to inform my workers about the changes. So, how to do that? How to inform my various workers, so my application, that I have just pushed some modification of the code and that the application have to restart, do some various stuff, reload, feature flipping store or ACL store, etc. I prefer to stick to the Unix philosophy. So thinking that there is one tool to do one thing, and we don't have to develop a bunch of tools that do everything but the coffee, and we need something more straightforward in what we want to do. So what I love to use is signals. So when I run some other Unix bash scripting stuff, when I am doing some actions in my hook scripts, I just push a signal in the Unix socket using the socket command, and it just write a message, which is just signal db migrated when the migration is done. And it writes the message on the application socks. And now I can use a Node.js instance to read this socket and act regarding to the message pushed in the socket. So I've got a Node.js instance that is my coordinator, my orchestrator. So I simply create a new Node server with a socket. I just read the application socket and read the various messages. And when a message is written by my various scripts, I just test the signal message and execute some code in this kind of situation. So it's really easy to act and react when my scripts are run by my different Git hooks functions. And after that, I use streams from Node, so real Node streams, for functional reactive programming, so for triggering some action on my workers. So what if my Node.js orchestrator suddenly crashed? Because that happens. Well, it's easy. You just have to restart it. And it creates a new socket, and your hook scripts can write it right in the socket again, and everything's okay. It's just an orchestrator. It's just here to run some script or trigger some other action, but it's not critical to have it to alive at any time. It can crash. You just restart it, and it's okay. If you need to scale, it's easy. You just have to use detached workers, which are not relied directly to the coordinator, but that can run on the other side, and it's okay. If you need to roll back a database, it's easy to just be careful to never be destructive on your database when you run a migration. Your migration, if it's the migration modifies the schema of the database, you have to maintain the whole schema during the time of the feature flip. And when it's okay, and when you finally disable the flag and you use the feature in production for everyone, then you are allowed to remove the whole schema in your database. During the overlap time, always maintain both schemas. There is an excellent illustration of that on how to migrate from a kind of database to another one using feature flipping on the internet. There is a link in another slide, and it's really instructive. And if you need to update your ACL or your feature flag, just filter on your git commits to be sure that the commit that is pushed or your branch that you are pushing and staging is allowed to update the various control list or feature flags, and it finally run easily. So, how to transmit the message from the coordinator that is reading the various actions from the Git hook scripts and pass them to the various dedicated workers. Well, you can use brokers. There is 0MQ, there is Redis, there is MQTT if you're working with IoT, and other ones. So it's easy to use. What I do often is to restart a worker. You are pushing a new feature in production, your code is ready, your code is deployed, and you have to restart your application, your Node application, to take this code in consideration and restart it. I often finally fork my server or my application and just connect to the broker socket and wait for the coordinator to pass message. When the coordinator asks for a restart, then I restart the fork and relaunch it. And if you have 10,000 of workers that are running in production, this is not a problem because they all will receive the signal at a different point in the time. So they are restarting in a way in the queue, and finally you always have your system up and running. But I guess it will be more simple in the future when the workers that Anna just showed us before were ready to use in production. About flags and the feature flags. It's sometimes really easy to finally reload them. When you start your application, you just create a new controls with it, which is an ACL store. Stored in memory or any other backend as you want, and you define two kind of options. The criterias. Criterias are on which criteria you enable or disable a flag for a dedicated user. So it can be just regarding to the context, to the time, to every action or every options that you have in your execution context or your database, but it can also be based on ACLs. So you can, in your criteria, defines a criteria that is this group can access to this resource. And you've got the features, and features are just if an association between criteria and a feature namespace. So you just have after to test it to enable or disable your feature in the code. To reload them, it's just easy as to listen the broker. And when you receive the ACL reload message, you first remove all of the authorization, so you disable all your ACL. Then you've got a new set of permission passed in the payload, so you just have to allow this new whole set of permissions to your store. Then you've got another set of features that you pass to your flags config. You just reload it, and it's okay. You don't have to restart your application. You just have to reload the set of control list and features, and it works. What about various API endpoints? I really like GraphQL too, but sometimes you have to deal with some REST API, classical REST API, and it's fine for many use cases. So one thing I really like is that to define dynamic endpoint in which you just post a message to this URL, which is an API slash a name of the endpoint. And the first thing you do is to test your endpoint, test if the feature is enabled for your user. So are your user allowed to access to the endpoint or not? If yes, you just dynamically load the controller and initialize it in your application and then send 2000 message status. Otherwise, you just send a 401 status message, and you can easily, per user, enable or disable your various endpoints per user or per context or per whatever you want. Just based on a feature flag, you can enable or disable your endpoint in your APIs, which is pretty useful. And after, it's masked by my link ribbon, but you just have to call your API as you do every time, and it's okay. I just recall you the various HTTP codes that I use every time. 204 is no content, 303 is see other, so moved resource, which is pretty useful when you're dealing with feature flags, because you sometimes open an API point and finally move it to another side due to your feature flag. So it's easy in this kind of situation to, when you enable a flag and you enable a feature which is moving a endpoint to balance your traffic to another endpoint, so temporary redirect, and the unauthorized and forbidden, which are the ones you use the most when you are doing with feature flags, etc. So about feature flags and ACLs. On the server side, so inside the workers, about the REST API, you can use dynamic endpoints. You can serve your relevant ACL through your API, so it's easy to push the ACL and the features to your clients. You use a signed payload to do that, because your whole payload contains your ACL and your feature flag list. So if it's intercepted and a malicious user wants to modify it to access some features that he's not allowed to access, you have to prevent it. And to prevent it, a signed payload is the best solution, because it can't modify the payload and the ACL and the flags without modifying the signatures. So it's a good way to prevent any malicious access. On the authorization, if you can, please use Json Web Token. So you can easily, when you push a new feature in production, inform your clients that you've got a new version, and you need to re-auth by itself to get a new Json Web Token, so new rights, new permissions. So your clients can do that in the background. It's not mandatory for your users to re-auth in their clients. It can be done in the background, but it updates the permissions and the flags in the GWT payload, so it's okay. Feel free to block the various requests and the various redirects in your API on your endpoint when you update or enable or disable your features. But never forget to properly deny the resource, because if your user is accessing a resource and you enabling a feature at the same time and is trying to access it, you have to properly inform him or her that there is a problem and is not allowed anymore to access the endpoint, or the endpoint have moved or something like this. So handle it properly in your client, and feel free to self-reload the client in the background. So in the client side, because we're talking about Node.js, but you are also talking about JavaScript, and clients are JavaScript stuff. Forget WebSockets and use the push API, which is the best thing since the sliced bread, I guess. It's really easy to implement in the client. You just have to send a notification from the server with the subscription ID, the payload, some options, and you've got a premise that you can react it. So it's easy to do. You can, in your application, use a service worker. In the service worker, you just listen to the push event, check the payload, get the payload, then then reload the ACL stuff, and eventually show a notification in your client that inform him that the code has changed, the new features are enabled, or new features have been disabled. And you keep your customers informed about what is happening in the back of the application. About some best practice and more. One good thing I'd like to do when I'm doing front-end development and feature flipping is to do some smart code splitting. For instance, if I need to get some component or something like this, I first test my flag in my client. Is a component allowed for a user or not? If not, I reject the premise with a 403 error because I like to use status HTTP codes in my client directly for the error. And if the user is allowed to use the component, then I do a dynamic import. This is a Lodash import in a chunk name Lodash. And so I can modify my component, use my component, generate my component. And this code is pretty smart because I don't load the huge code base in my client with any features, even the disabled features in the client. I just load the core stuff and I enable or disable the various parts of my application regarding the rights and the permissions of my users to use. Another advanced use of feature flags is the possibility to get simple monitoring view. There is a server dedicated to feature flipping, namely Unleash. And the problem with Unleash, in my opinion, is that this is a server, this is a centralized server, and every time the code base, even on the server or on the client, need to check a feature and ask for a permission to access or not feature. The client or the server have to ask the server, make a request to the Unleash server, test it, get the response, and then enable or disable the feature. Problem is, if the Unleash server is unreachable for any kind of reason, you're stuck with a code base that is not perfectly complete. So I prefer to embed all the features, the flags, the control list in the application or in the code base of the server side or in the client and dynamically reload them. But even if I do that, it's sometimes useful for marketing teams or other teams to see which features are currently enabled or disabled, or even have some dynamic systems that when you just toggle a switch, made an automatic commit and push it in production in the staging branch, it's possible finally. So so feel free to develop some simple monitoring view or interacting views that are stuck on the controller, Node.js controller, or another part or another sub-application just dedicated to see the feature flags on the control list and how to access them. Finally, I guess DevOps are just here to ensure that our users are not to suffer our various mistakes during the continuous delivery, and we are just humans, we are making mistakes. Node.js, streams, hook scripts in Git are really powerful, and you can use them in any way you want. It's simple, it's easy, and it's really smart when you finally embed it in your application. I'm Mads. I'm a tech evangelist at Always Data, which is a hosting provider, hosting PaaS provider. We're working on some various implementation. We're working with various technologies, and we try to inform the various communities about our work and what we discover when we test new technologies. If you've got any questions, unfortunately I have to take a plane, so I'm in a little rush, but feel free to wave me in GitHub, in Twitter, by mail, or whatever channel you want. I'm always here to answer your question and discuss with you about those various stuff with pleasure. Thank you so much.